Assalamualaikum warahmatullahi wabarakatuh. So for today, our group, which is Group D, will present about matrix inverse 3 by 3. Before we start, let me introduce to all of you our group member, which is me, Sarah, Anis and Fahmi. What is matrix inverse? Matrix inverse is a number which when multiplied by the given number result in the multiplicative identity 1. A inverse is an inverse of a matrix A. If we can't find matrix A inverse, we call A is a singular matrix, which is determinant A equal to 0. There is 5 steps to solve matrix 3 by 3. Step 1. Find determinant. To find determinant 3 by 3, copy the first and second column of the matrix to form 4th and 5th columns. And then do a cross calculation for each line like the diagrams below by using the formula given. As you can see, the formula starts with addition from the top left to the bottom right. After the first formula is settled, then continue with the bottom left to the top right formula, but it has to use subtraction.
Step 2 is find A minor. Minor of matrix for a particular element in the matrix is defined as the matrix obtained after deleting the row and column of the matrix in which that particular element lies. Example, to find a minor, all the alphabet that on the lines with A minor have to discard it or ignore it. Alphabet that not in the line with A minor required to do a cross calculation. For example, EI minus FG have to do a cross calculation by using subtraction formula. Continue to solve all the minor by using the same formula.
Step 3. Find cofactor. To find cofactor, B minor, D minor, F minor and H minor have to add a negative symbol in front of the alphabet or the value. Step 4. Find adjoint. To find adjoint, the position of cofactor have to change. Replace parallel position to a vertical and vertical to parallel. But the negative in front of the alphabet or value still need to write it down. Lastly is step 5, which is replace result in formula. To find A inverse, the formula is 1 over determinant A multiplied by adjoint A. So let's start with our example 1 that have been given in slide to find matrix inverse of A. Firstly, you have to find determinant. To find determinant, you have to do a cross calculation. As you can see in slide, there is an example for you to follow. Firstly, you have to find the value of the top left to the bottom right. There is an example that shows that 2 multiplied by negative 2 multiplied by negative 3 plus the next column, which is 1 multiplied by 4 multiplied with negative 1 plus next column 0 multiplied by 3 multiplied by negative 1. After you settle all the part, you have to put subtraction to continue to the next part, which is from the bottom left to the top right. As you can see in formula, you have to multiply negative 1 multiplied by negative 2 multiplied by 0 minus next column negative 1 multiplied by 4 multiplied by 2 minus negative 3 multiplied by 3 multiplied by 1, and the total we get is 25. Second step, which is find minor. As you guys know, I already explained to you how to find minor. You have to ignore all the minor that in the same line of the minor that you guys want to find. As you can see in slide, you have to do a multiplication and subtraction to find a minor. You have to do a cross calculation, which is you have to multiply negative. For example, in M11, you have to multiply negative 2 and negative 3 and minus 4 multiplied by negative 1 to get 10. So for the next step, you have to follow the same formula as before, which is if you do the same formula for M21, you will get negative 3, M31 you will get 4, M12 negative 5, M22 negative 6, M32 8, M13 negative 5, M23 negative 1, and lastly M33 negative 7. After you do a calculation to find a minor, you have to do this method to put all the minor inside the box. which is you can write A minor equal to 10, negative 5, negative 5, negative 3, negative 6, negative 1, 4, 8, and negative 7 inside all the column and row. Step 3, which is find cofactor. To find cofactor, you have to put negative in front of B minor, D minor, F minor, and H minor. If the minor that you already get have a negative and then you add another negative, it will be positive, as we can see in the second example in the A cofactor inside the slide. Step 4, which is find adjoint. To find adjoint, you have to rotate the column that you already get from A minor. As you can see in slide, A adjoint equal to 10, 3, and 4 for the first column, and the second column is become 5, negative 6, negative 8, and the last one is negative 5, 1, and negative 7. The last step, which is step 5, have to find A inverse. To find A inverse, you have to do a formula 1 over determinant A multiply with adjoint A. You have to do a multiplication to find the final answer for A inverse. So let's do the exercise to find the matrix inverse that have been given in slide. So from the exercise that have been given, let's check the answer. First is determinant. The determinant is negative 30. For minor is M11 equal to 20, M21 is 10, M31 is negative 20, M12 equal to negative 13, M22 equal to negative 8, and M32 equal to 4. M13 equal to negative 21, M23 equal to negative 6, and lastly M33 equal to 18. So after you get all the answer for minor, you have to write it down like this. As you guys know, to find cofactor, you have to put negative in front of B minor, D minor, F minor, and H minor. As you can see in slide, there is the answer for the cofactor. The next step, you have to find the adjoint. As you guys know, if you want to find the adjoint, you have to rotate the column from the cofactor. You can see in slide for the answer. So the last step, which is you have to find the inverse. To find inverse, you have to write it down 1 over negative 30 multiplied by the adjoint. So the matrix inverse equal to negative 2 over 3, 1 over 3, 2 over 3, negative 13 over 30, 4 over 15, 2 over 15, 7 over 10, negative 1 over 5, and negative 3 over 5. In conclusion, in mathematics, an inverse matrix is a useful tool. We have learned about the inverse matrix, its characteristic, and several applications. It can be utilized to solve the majority of tough problems. It is used to solve linear equations as well as other mathematical functions like calculus, optics, and quantum physics. It has several real-world applications which has led it having an important role in mathematics. That's all from us. Thank you very much.